So the reason these logarithms come in really handy is especially if we're trying to solve some equations, because we saw that logarithms and exponential functions are inverses of each other, right? So if I'm trying to solve maybe an equation that has exponential functions in it, I can actually use logarithms to solve that equation. So for example, I might give you something like this. 2 to the x minus 4 is equal to 8 squared. There's a couple of ways to do this problem. First of all, I could try to just rewrite this so that they're both bases of 2. We already said that's a way to solve this. In fact, I could do this pretty easily. 8 is really 2 cubed, right? But then that will be 2 cubed squared. So that will really be 2 to the 6th power, right? 3 times 2. And then my rule said if these two bases are the same, then that means that their exponents have to always also be the same. So that means that x minus 4 has to be equal to 6. And so x is equal to 10. So some of these we can do without necessarily having to take logarithms of both sides and just try to get the bases equal to each other. But if I want to do one like, well, I guess most of the things I can do. Let's do one like this, for example. Okay. 3 to the x is equal to 91. I want to figure out what x is equal to. I could actually just take the log base 3 of both sides as an equation, and now what I can do is bring this x down to the front, right, using my log properties. And then log base 3 of 3 is going to be equal to 1, right? 3 to the 1st power. And so I end up getting x is really just equal to log base 3 of 91. So this technique comes in really handy when I can't write both sides as a power, right? I can't write 91 as a power of 3, right? I guess that one, in this case, actually this is a power of 3. Log base 3 of 91 is going to be 4. I'm sorry, that's 81. So no, this is actually fine. So the idea here is this is actually a number, log base 3 of 91, and so that's perfectly fine as an answer. So I can actually just go through and take the log of both sides and figure this out. So how about one like this? 6 to the 2x power is equal to 200. In this case, I'm trying to get the x out of the exponent, right, to solve this. So what I can do is actually just take the log base 6 of both sides. You want to pick the log base that the base is here, because the idea is when you take log base 6 of 6, it cancels out and becomes 1, right? So this will be log base 6 of 6 to the 2x is equal to log base 6 of 200. And then I can bring down the 2x to the front. And I'm left with log base 6 of 6 right here. And then log base 6 of 200, it's an ugly number, we don't know what it is, we don't care. It's still an exact answer. Then log base 6 of 6, that's just equal to 1, right? So I end up with this equation, 2x is equal to log base 6 of 200. Now we can just divide both sides by 2. And I'll get that x is equal to log base 6 of 200 over 2. And again, we don't care that this is a nice, neat answer. We just care that this is a number. Log base 6 of 200 is some number. and then 2 is some number. If we wanted to, we could figure this out, putting in a calculator, change the base, but this is a perfectly good answer right here. What if I gave you one like this, e to the 2x plus 1 is equal to 70. How would I get the 2x plus 1 out of the exponent there?
Take both sides by log e, or by natural.
Right, so the natural log, or log base e. So I'll take the natural log of e to the 2x plus 1 is equal to the natural log of 70. Now I can bring down this entire exponent to the front, so 2x plus 1. And then I'll have natural log of e left over. Okay. But natural log of e is just equal to 1, right? So that goes away. I'm just left with 2x plus 1 is equal to the natural logarithm of 70. And now we just want to solve this for x by any means possible. So to solve this for x, I can just subtract over the 1. And then I can just divide by 2, right? And again, for a lot of these, you're going to get really ugly answers like this. But it's still a perfectly legitimate good answer. Natural log of 70 minus 1 divided by 2, and we can solve that equation like that. So in general, if we have an x in an exponent, and we need to get it out, or a variable in the exponent, we can always take the logarithm of both of those sides and try to get the exponent out. Especially in those cases where we can't rewrite each side as the same base. Okay. So those are our two kinds of problems we're going to be dealing with. The first couple we looked at, we have two where you can write them as the same base on both sides. In that case, you can take the logarithm, but you don't actually have to because you can just rewrite them and set the exponents equal to each other. Or a case like this where you can't really write 200 as the base of 6, so you actually have to take the logarithm of both sides and then deal with it like that. Okay. So that's how to get the exponent out of the, how to get the x value out of the exponent. And we're using this basic property that if you take the log base b of b to the x, that you'll always get whatever's up there, right? Because you can bring down the x and then log base b of 1, b to the first power. 1, so you always get x there. So that's the property we've been kind of using, like right here, right? As you do more of these, you don't have to do this step necessarily. You'll just know that natural log of e to the 2x plus 1. Oh, natural log of e, cancel out. Now I'm just going to put 2x plus 1. But there's another rule that we're going to use to get rid of logarithms. So that's how to get rid of exponentials. But if I want to get rid of a logarithm, this rule also applies. If you take a power to a log of the exact same base, you'll get whatever you're taking the logarithm of in that particular case. So a to log base a of x will just be equal to x. So we can do a few of these exact same examples using this rule. So for example, log base 2x is equal to 5. Well, in this case, in the equation, I can just take both sides as a power of whatever I want to. So what's probably the smart power here? If I take both of these as a power of 2, then in this case I can use this rule that this will cancel out with this. And I'll just get x is equal to 2 to the 5th, which is just 32. So this is a trick that I'm going to use to try to get rid of logarithms. So how about let's try another one here. 7 minus 2 log base 2 of x is equal to 4. I want to get that x out of the logarithm. What do you think? What's probably the first thing we should take care of?
Getting the 2 back up as a power.
Right, but we need to, before we can do that, actually, I want to try to get rid of all this stuff here. Okay, so I want to try to get to where on the left side, all it is the logarithm base 2 of x. So I can subtract the 7 over, right? And I'll get negative 3. This is a negative 2 log base 2 of x. Now we can divide by negative 2 on both sides. So this will become log base 2 of x is equal to 3 halves. And now we can take both sides as a power of 2. Because I'm trying to get that x out of inside of the logarithm. And then 2 log base 2, that will cancel out. I'll get x is equal to 2 to the 3 halves power, which is the square root of 8. Is that alright? 2 cubed is 8, and then 1 half. So I'm using the rules that we used from a couple lectures ago to figure that out. So I can get that, I can figure that value out. What about this one? Natural log of x squared is equal to 6. I can actually just raise both sides. What base am I going to use here to get rid of the natural log?
E.
Right, so I'll use a base of e. So e to the natural log of x squared is equal to e to the 6. You have to do it to both sides, so be careful there. The e and the natural log, they'll go away. And I'll end up with x squared is equal to e to the 6th. Now this one's a little tricky from here out. I have to take the square root of both sides, right? So I'll get square root of e to the 6th right here, but what do I get on the left?
Plus or minus x.
Yeah, that's right, you're on the right track. It's absolute value of x, right? Because it's the square root of x squared. So this will become the plus or minus value of the square root of e to the 6th. And this is a perfectly fine answer, square root of e to the 6th. Don't try to simplify that anymore. That's an exact answer. What about one like this? Log base 4 of x plus log base 4 of 5 is equal to 2. This one's a little trickier.
Wouldn't you combine them to begin with before you start moving stuff?
Right, so I couldn't get the trick past you, right?
Sorry.
That's fine. Yeah, in this case you can use your rules to make this a little simpler to solve, right? So since these are both the exact same log base, I can actually combine these using my rule from before into log base 4 of 5 times x is equal to 2. Or x times 5. And now you would raise both sides to the power of 4, right? So I can say, oh, that's 4. I'll raise both sides to the power of 4 to get rid of the logarithm. And so 4, log base 4, that cancels out. And I'm just left with 5x is equal to 16. So x is equal to 16 over 5. So there's a lot of little tricks like that that you can go after. Maybe we'll do one more that's similar to that. How about this guy? Log base 10 4x minus log base 10 of x minus 2 is equal to 1. Again, the smart thing is probably to try to combine these first. So this will really be log base 10 of 4x over x minus 2, right? Using our logarithm combination rules. And all of that's still equal to 1. So then I can raise both sides. I'm going to try to get rid of the log base 10. So I'll raise both sides as a power of 10. So I get all that up there, and then 10 to the first power on the right. This 10 and this log base 10 will cancel out, and then I'm just left with 4x over x minus 2 is equal to 10. And then I can solve this by multiplying both sides by x minus 2. When was the situation I said I couldn't do that in? Do you remember that? This is fine here because it's an equation. But if this had been an inequality, then you have to use the chart, the big chart, to figure it out. You'd have to subtract the 10 over. But in equations, it's fine. This works out good. So I'll get 4x is equal to 10 times x minus 2 is 10x minus 20. And then I'll subtract over the 10x, so minus 6x is equal to minus 20. So x will be 20 divided by 6. So that one's kind of a lot of work to go through. But if you're smart about it and you combine early, then you can figure out the answer pretty quickly. I think I'm going to bump back to one more problem that's the opposite. So using the logarithms just to make sure we're over here. So how about this one? 24 plus e to the 4 minus x is equal to 22. In this case, I'm trying to get the x out of the exponent, right? So this is the opposite problem here. Here I was trying to get the x out of the logarithm. So what are you going to try to do here?
First thing I did is I moved the 24 over to kind of make it cleaner.
Right, yeah. If you can clean it up first, that's the best thing to do. Plus, the only thing I want over here is e to a power, right? So I can subtract the 24 from both sides, and I'll just get a negative 2 here. Okay. Now what we're going to try to do.
I hate that e.
Remember, the e is just a number, right? It's just, what would you do if it was like 3 to the 4 minus x? To get that out of there. If it was a 3, you would take log base 3 of both sides, right?
So a natural log to both sides?
Right, it would take natural log of both sides.
Okay.
So we'll take the natural log of both sides. And then I can bring the 4 minus x down to the front, and the natural log of e just turns to 1. So I'll get 4 minus x is equal to the natural log of negative 2. But there's a problem with this. We can't take the natural log of a negative number. We can't take the logarithm of a negative number at all, right? Because you can never raise e to a power and get a negative number. So this, in fact, doesn't have a solution. And that's actually, I wanted to bring that up. Because we said, when we were looking at our log rules, we said if you take log base b of b, it's just always equal to 1, right? If you take a log base b of 1, it's always equal to 0. If you take a log base b of 0, we said that's undefined, right? You'll never raise a number to a power to get 0. It's not 0 already. And the same thing happens if you try to take the log of a negative number. That's also undefined. So anytime you go through and you end up taking a logarithm, natural log, log base 3, no matter what the log is of a negative number, that's an automatic red flag, and you can just go ahead and stop and say, well, there's no solution for that then. Because I'll never raise anything that's positive to a power if you end up getting a negative number.